We'll proceed in vector and commercial calculus. Vector and commercial calculus, this is the topic that we are pursuing. Vector and energy calculation. Vector and energy calculation. In that respect, we are into circulation density. Circulation density means if I know what is the energy computation as far as closed loop is concerned, there is a closed loop, and when the loop is closed, then in that okay, so what I am trying to say, okay, so what I'm trying to say is that if there is a loop, if there is a loop, if this is a kind of a closed loop, this is a closed loop from point here and it is coming to point here again, closed loop. This is a closed loop. Now, if there is any vector field, okay, so if there is any vector field, as always I say, there is an energy source out here. There is one energy source out here, and because of energy source, there is a vector field. And with this vector field, if there is an energy source, then there is a vector field. And with this vector field, now this is the vector field. There is one bolt that is pierced inside this line, and bolt would move like this only. When there is a vector field like this, then bolt is moving like this and coming back to the same location. Bolt is moved, vector force is like this, and bolt is moving from here and coming back to the same location. If that is the scenario, how much is the work done by the force field? This is the general thing that is generally found in the book, that what is the work done by the force. Or someone can say how much is the energy that is dissipated, that is consumed from the energy source. How much is the energy that is consumed from the energy source when this is the force field and item is moving in a kind of a circle in a closed loop. Then it is as usual force vector dot displacement vector. As per calculus, force vector dot d of position vector. Force vector dot d of position vector. If that is the scenario, force vector dot d of position vector, then now I have to know it is path dependent or path independent. That is another scenario. Consider it is path dependent. If it is path independent, if it is path independent, then coming from the moving an item from this point, and when it is coming back to the same point, item is moving from this point and coming back to the same point. If the force field is path independent, if the force field is path independent, then work done by the energy source that is producing the force field is zero. No work done, because it is path independent and work done is dependent upon the begin path and end path. Here, begin path and end path are same point. No work done. If there is work done in a closed loop, item is moving along a line, along a curve, and it is coming back to the same location, and there is a work done. Then force field is called path dependent. Can you give me one example of path dependent? Okay, one example can be force field is yi minus xj. I believe I am right. Okay, minus yi plus xj, minus yi plus xj, minus yi plus xj, minus yi plus xj. Now, when y is 0, along if this is centered at the origin, this is x-axis, that is y equal to 0. If this is x-axis, then y equal to 0. If that is the case, then it is minus yi plus xj, minus y, I'm sorry, yi minus xj. Then Then up, yeah. Then it is in downward direction. The vector field is yi minus xj. When y equal to 0 on x-axis, the vector is x minus xj. Means it is in this direction. It is in this direction here. At point 1 comma 1, it is 1 minus j. 1 minus j. Then it is in this direction. So it is tangential kind of, it is in a kind of, in a circular way. Okay, if that is the case, then this is, I am saying this is path dependent. Path dependent means energy computation is there. Can you show me? Don't uh, don't prove it through mathematics. This is what anyone would say. Don't prove it through mathematics. Can you tell me it is path dependent? If it is path dependent, then net energy from one point and coming back to the same point, net energy computation is non-zero. That is path dependent. That is path dependent. Okay, thank you very much. Can you give me one example? Okay, I'm giving you one example. One person is kind of cycling. He is on bicycle. This example probably would not be available in any of the book. A person is on bicycle. A person is sitting on the bicycle and he is driving now. When he is paddling, okay, consider this is the consider this consider this is the paddle. This is the real life example. Consider this is the center and this is the kind of line and he is paddling like this. Bicycle, he is paddling like this. Now this is his leg. This is his kind of feet, the bottom part of the kind, okay, and he is pushing like this from leg. He is pushing this axle like this, then like this, then like this. Okay, then it is rotating. Now if that person is using his feet and it is going like this and then it is coming back like this at this location, how much is the work done? If it is person is applying through his leg, he is applying energy like this, force like this. When he is applying force like this, then at this point, when he is applying force like this, then at this point, when he is applying force and this axle is moving and coming back to this location, person is losing energy. Person is losing energy. Okay, if he is losing energy, means there is a work done. There is a work done. What is the direction of the work? If it is a circle, if it is a circle, if person is rotating kind of his leg, then it is a circle. And in circle, person leg is like this and he is rotating like this. Displacement and his the force are in same direction. Displacement and force are in same direction. Though the force is also circular and displacement is also circular. What is displacement? Displacement is x square plus y square equal to a square. Y equal to a square minus x square. Y equal to a square minus x square. That is the displacement. A square minus x square. Square root y equal to. Whereas, so the displacement direction is completely circular, whereas the force direction is tangential at each point. The force vector is kind of display. If I talk about displacement line, then that is a circular. If I talk about displacement vector, then again that is tangential. If I talk about force vector, that is also tangential. Okay, consider my force vector is yi minus xj. This is what I am talking. Yi minus xj. Okay, now can you prove mathematically that there is energy involved there? It is not zero. If it is not zero and person is moving something through force and he is coming back to same location and there is energy involved and it is not zero, means the force is path dependent. Okay, how much is the energy calculation? Force vector dot with the position vector. F dot dp. F1 dx plus f2 dy, f1 dx plus f2 dy. F1 is y dx, y dx minus x dy. Funny, right? Y dx minus x dy. Y is square root of a square minus x square dx minus x d of y. Dy is dy by dx into dx. D of square root of a square minus x square by dx into dx minus x by square root of a square minus x square. Then it will become minus x square by a square minus x square. This side it is y dx square root of a square minus x square. That side minus x by square root of a square minus x square. If you take this side, then it becomes a square minus x square minus x square. A minus 2x square by square root of a square minus x square dx. Whatever it comes, x is minus a to a and y, x is minus a to a and y is minus square root of a square minus x square to plus square root of a square minus x square. That is the energy computation. Okay, so this is now you have to prove it. This is path dependent, not path independent. Now tell me any gx, any potential function for which partial derivative d if if f1 dx f1 dx plus f2 dy, if it resolves in any if it resolves in any potential function, if it resolves in any potential function g, then dg by dx should be f1, dg by dy should be f2. Now tell me any potential function for which the dg by dx is f1, dg by dy is f2. Okay, try to find the potential function g, then it is x dy y dx minus x dy. Now y dx, okay, if y dx, if it is a path independent, if it is path independent, then f1 is y. If f1 is y, then df1 by dx, sorry, f1 is dg by dx, g is f1 dx, then y dx is yx. So g, the net integration g equal to yx plus some function in y, cy. Makes sense, right? I have to get g, that is the integration of f1 dx plus f2 dy. That is y dx minus x dy. Okay, that integration should come to g, where dg by dx is f1, dg by dy is f2. Now g equal to dg by dx equal to f1, that is y. Then g equal to y dx yx. Now dg by dy, dg by dy should be f2. Okay, if it is f2, then the okay, g equal to yx, dg by dx is equal to y. This is what we are saying. In that case, I can write g equal to yx plus any function of y only. That's why dg by dx is y plus 0. Now dg by dy, if I say, then it is x plus derivative of that function c. I call it cy. Now dg by dy is minus x equal to x minus x equal to x plus derivative of cy. Cy equal to minus 2x. Then derivative of cy equal to minus 2x. Now cy will have x also. Where I want cy not, there should not be any x there. If that is the case, then it is not possible. Means there it is not possible and it is path dependent. But this is path dependent, right? If I am using my feet to push a bicycle and this is axle, and I am making force, that is y I minus xj, and then it is like that, and if I coming back to same location, then the energy I am imparting energy. Okay, when you want impart the energy, anyone would ask, you are giving speeches now that this will happen this way, this will happen that way. Okay, now you drive the bicycle in path independent way. Is it possible? Yeah, it's possible. Okay, Now, if this is the kind of center of the axle which I am rotating, okay, now I'll rotate in a fashion that I'll impart energy in this direction. Hop, hop, hop. When it is here, I'll impart energy in this direction. When it is here, I'll impart energy in this direction. Now I'm imparting energy perpendicular to the axle. Now impart energy along the axle. How? Now see, then it will not move. If you impart energy, if it is not moving, then it is path independent. One fundamental is okay. Means your force is xi plus yj. Force is xi plus yj. If force is xi plus yj, then there is no energy we are imparting now. There is no energy we are imparting now. In that case, then prove it that it is path independent. Xi plus yj, x dx, that is x square by 2 is g. X square by 2 plus any function over y, cy, dg by dy. If I say dg by dy, then first is gone, 0, plus derivative of c. Derivative of c. Okay, derivative of c equal to 0. This is what I think so. Okay, the function is xi plus yj, x dx plus y dy, x dx plus y dy. Okay, along path independence. So can I get any algebraic function g for which dg by dx is x, dg by dy is y. Okay, now x dx, now x d dx equal to dg by dx, g equal to x dx, x dx integration is x square by 2, d equal to x square by 2 plus any function over cy. Then if I differentiate it, then dg by dy equal to 0 plus derivative of function c. dg by dy is y equal to derivative of function y square by 2. X square by 2 plus y square by 2. If there is any algebraic function x square by 2 y plus y square by 2, x square by 2 plus y square by 2, then it is then it's possible that partial derivative along x axis is x, partial derivative along y axis is y. Then it is possible. Work done in a closed loop. If your force is along the radial of the cycle, the axle, where axle or wherever the chain is there, their paddle is there. That paddle, if your force is like this along this direction, it will not move at all because of you. So net energy because of the energy source by the leg is 0. So in a closed loop, it will be 0. Okay, but in closed loop, okay, so this is something that we can calculate the work. Okay, this is something that we can test independent or not independent. Okay, so the way to calculate independent or not independent is try to integrate f1 with dx and get g plus a function over y, that is cy. f1, integrate f1 with dx, it becomes g plus function over cy. Okay, now differentiate with y. Whatever you get g plus cy, differentiate with y. That will become dg by dy plus derivative of cy. That is dg by dy. Now replace dg by dy. dg by dy equal to f2 and get the cy the way we did. Okay, now that is the way we try to get any algebraic function g for which partial derivative along x-axis is f1, partial derivative along y-axis is f2. If it exists, then it is path independent. Otherwise, it is path dependent. Otherwise, it is path dependent. Can there be another example? One example, famous example is y cos x. Y cos xi, y cos xi, okay, y cos xi plus y plus sin x. This is another example. Y cos x is f1. If I integrate with x, then it becomes y sin x. y sin x, y sin x, so gx equal to y sin x plus function of y sin x plus any function of y, say c and in bracket y bracket close. Okay, then df1, I'm sorry, I'm saying that the kind of f1 dx is g, because dg by dx is f1 as per path independence. Now g equal to f1 dx, that is y cos x integration, that is y sin x. Y sin x plus function over y, cy is g. dg by dy will become now sin x, y sin x sin x plus derivative of cy, and dg by dy here is y plus sin x. Y plus sin x equal to sin x plus derivative of c, sin x gone, derivative of c is y, c equal to y square by 2. Means if I have algebraic function y sin x plus y square by 2, then means if I have integration, net resultant is y sin x plus y square by 2, then its partial derivative along x axis and y axis is y cos x and y plus sin x. Someone can try y sin x plus y square by 2, dg by dx will become y cos x, that is gone, dg by dy, then it becomes sin x plus y. Okay, if someone is driving by bicycle with equation y cos x I, so the vector at every moment y cos x I, y cos x I plus y plus sin x j. If that is a formula, means if this is x axis, this is y axis. Okay, at this location we have y, but x is 0. Y plus cos x. Then here the y plus cos x I. Then y is, consider y is 1. 1 plus cos 0 is 1. 1 plus 1, 2. 2i. So along this direction is like this. His leg is like this, that is 2. And that is y plus sin x. X is 0. Then it is sin x is 0. Y is 1. 1j. 2i plus 1j. 2i plus 1j will be in this direction. I plus j will be exactly 45 degree. 2i plus j will be around 30 degree or something like that. This much. Okay. So instead of he is paddling exactly perpendicular to the line, if he is paddling some angle at 2i plus j, when x is 0 and y is 1. Now when it is here, then x is 1, y is 1. In that case, y plus cos x. Okay, 1 plus cos 1 in radian we can say. I plus 1 cos x, y cos x. Sorry, earlier it was y cos x, 1 into 1, 1, I plus j. If it is paddling in 45-degree direction at this moment, when it is at point 1 comma 1, then y is again 1 and x is 1. Cos 1 in radian someone can calculate, and y 1 is cos x, whatever it is, I plus y is 1 cos 1, whatever comes j, whatever angle comes. So he is changing his leg angle in a way that here it is at 45 degree from x axis, here something else, here something else. He is changing his foot like that. If keep on changing like this, then there is no energy that is going from his body. This proves that some direction he is losing energy, some direction he is gaining energy. If it is happening like that, if he comes back at point A again, then no energy lost from his leg. Okay, but it is theoretically, practically, I don't know how it would be, but this is how it is. Okay, so this is path dependence and path independence. Other formula is if g equal to f1, dg by dx equal to f1, dg by dy equal to f2, then dg by dx in again differentiate with the y, dg by dx dy equal to df1 by dy. dg by dy dx equal to df2 by dx. If that is the case, then d by dx dy equal to dg by dy dx. They are equal to each other. In that sense, df1 by dy equal to df2 by dx. Then this is path independent again. Okay, now people can compute so path independence from a formula df2 by dx minus df1 by dy. If that is the scenario equal to 0, then it is again path independent. Okay, now let's compute path independence in a way. Okay, in a way, consider force vector is xi plus yj. I don't remember what I said about xi plus yj. It is path independent or dependent. xi plus yj. xi plus yj. Okay. df2 by dx. xi plus yj. df2 by dx. df2 by dx is 0. df1 by dx 0. Okay. So df2 by dx is 0. df1 by dx is 0. Both are same. So it is path independent. But while calculating, this is called curl methodology. We have described it curl methodology. Curl methodology means df2 by dx, df1 by dy, df2 by dx, df1 by dy. We have demonstrated it that we consider that we are calculating the kind of what is df2 by dx. If I take one point here and one point here, if I connect through a vertical line, then I connect through horizontal line. Now df2 by dx, df2 by dx is along the horizontal line. F2 is changing as we move along x-axis. df1 by dy, if I go along vertical line, F1 is changing as move along the y-axis. Now this will produce a torque, and this df2 by dx also will produce a torque. If net torque is 0, then there is no path dependency. It is path independent as per the graph illustration. So df2 by dx minus df1 by dy equal to 0. But actually it came from a formula dg by dx equal to f1, dg by dy equal to f2, then it is path independent. Derive it again. dg by dx dy equal to df1 by dy, dg by dy dx equal to df2 by dx. Now since it is path independent and left side is same, then right side is also same. As per the graphical representation, if the net torque along 2 points, that is 2 point is connected through a line. Now I am connecting through a two line. One is vertical and one horizontal. If torque produced by df2 by df1 by dy, that is along this direction, and df2 by dx along this direction, if they nullify each other, then it is path independent. Please watch our previous video. Now, if force field is xi plus yj, then is it path independent or path dependent? Then I said dg by then df2 by dx 0, df1 by dy 0. It is path independent. What about yi minus xj? Force field is yi minus xj. It is circular now. First was radial. It is circular now. Yi minus xj. Yi minus xj. df2 by dx minus 1. df1 by dy 1. Not say path dependent. It is path dependent. Means in a closed loop, if I move from one point and back to the same point, then there will be work done. Earlier, xi plus yj, there won't be any work done. What about minus y plus 1i? Minus y plus 1i. yi minus xj is along the yi minus xj is along the circumference of a circle. yi minus xj. Y minus xj is along the circle. Okay, if that is the case, then it is path dependent, because if I calculate the work done along the full path, then since they are in same direction, then force magnitude yi minus xj is 2, 1 square plus 1 square root of 2. Okay, force magnitude is yi minus xj. Okay, it is square root of 2 and the distance is 2 pi. 2 pi into square root of 2. This is what I think so. Okay, let's try. Let's try it. Y minus xj. Y minus xj. What is the work done? Okay, if that is the case, then okay, let's go by this fundamental one. df2 by dx minus df1 by dy as per the Green's theorem. df2 by dx minus df1 by dy, whatever comes, whatever the net torque comes, integrate along dx dy and in a circular region, in a two-dimensional circular region, this will give the work done rather than going for f1 dx plus f2 dy. So if I do so, it becomes my df2 by dx is minus 1, df1 by dy is 1, minus 1, minus 1, minus 2, minus 2 minus 2 dx dy. If I convert into polar coordinate system, it will become r d theta dr. Minus 2 I can keep outside. R integration is r square by 2. Now radius, this circular region, radius is 0 to a square by 2. A square by 2. If radius is 1, then 1 by 2. Outside we have 2. 2 gone. 1. 2 gone, minus 1, minus 1, and then theta 0 to 2 pi, that is 2 pi. Okay, 2 pi into minus 1, around 2 pi. I believe I am talking right. R d theta dr, r square by 2, a square by 2, 0 to a means 1 by 2 and 2 outside gone. Now it is like that only. Okay, around minus pi is the work done. Okay, or I don't know, miss, I am right or not, or someone can kind of, what is dx dy? Dy integration over a circular region. Okay, dx dy integration over a circular region will give the area dx dy, 1 into dx dy, height is 1, and then if I try to calculate volume, I am trying to calculate the area, circular area. Okay, there is, that's what I was thinking, there is something wrong. Okay, now I am trying to calculate the work done by the force capital F equal to yi minus xj, that is df2 by dx minus df1 by dy, whatever the net torque is, dx dy, and integration over the this circular region. Now the df2 by dx minus df1 by dy is minus 2. Minus 2 I keep outside, dx dy. If I convert into polar coordinate system, then it is r d theta dr, r square by 2. If radius is 1, 1 by 2, 2 gone, minus 1, 2 pi. So it is 2 pi. But we converted dx dy, means we converted in a sense that x to theta. So we are calculating the upper half only, not the full. It will become now 4 pi. This is what I think so. I'll try another way. We'll try another way. We are trying to calculate integration of dx dy over a circular region. Okay, if that is the case, then x is minus a to a, minus 1 to 1, and y is minus square root of a square minus x square to square root of a square minus x square. If radius is 1, then 1 minus square root 1 minus x square root minus 2 square root 1 minus x. I believe I am all right. I am trying to calculate integration of dx dy over a circular region. Okay, that is x is minus a to a and y is minus a square root of a square minus x square to square root of a square minus x square, minus a to a minus a square root of a square minus x square to square root of a square minus x square. If I integrate y first, then it will become 2 into a square minus x square, 2 into a square root of a square minus x square. 2 I can keep outside. Anyway, outside already we have 2. So minus 4 will go outside. Now I have to integrate square root of a square minus x square. A square minus x square root dx. Now consider x equal to a cos theta. X equal to a cos theta. Then the square root of a square minus x square will become a sine theta. A sine theta. A cos theta. Okay, then it becomes a square. A is 1, so gone, no problem. Cos theta, sine theta. Okay, cos theta minus sine theta. If x equal to a cos theta, then dx equal to a minus sine theta d theta. Cos theta sine theta. Okay, minus minus outside minus is there. Outside 4 is also there. Okay, so now I have to integrate cos theta sine theta d theta. What is integration of cos theta sine theta? Okay, that someone has to find out. Okay, sine 2 theta. What is integration of sine 2 theta? Okay, I don't know that much. Okay, leave it. Let's go with another fundamental. Now, I don't think it will be very difficult. Okay, what is integration of cos square theta? What is integration of cos square theta? The integration of cos square theta equal to cos theta, integration of cos theta into cos theta, integration of cos square theta, that is integration of, now if I go integration by part, then cos theta integration of cos theta minus differentiation of cos theta and integration of cos theta, and then full full integration, then it will become cos theta sine theta. Cos theta sine theta. Integration of cos square theta is nothing but integration of cos theta into cos theta. So the first will become cos theta sine theta, and next will become differentiation of cos theta is minus sine theta, and integration of cos theta is sine theta. Sine square theta. Hope. I believe we are meandering. So let's go with the another way. Someone can find out what is the integration of cos theta sine theta. I don't know really. Another way is if I say dx dy, we are trying to calculate integration of dx dy, 1 into dx dy, where we have fxy is 1, that height is 1, and over dx dy, that is a circular plane, we are trying to find volume of a cylinder whose height is 1, and then this region is the integral. That is, indirectly we are trying to calculate the surface area of this circle, that is pi r square. Then that is pi. Surface area of the circle is pi. Surface area of the circle is pi. Then outside we have kept 2 pi. Okay, so 2 pi is the work done when under force xi yi minus xj I am moving an item. Under the force yi minus xj I am moving item in a circular fashion. Then in a closed loop the work done will be 2 pi. Okay, someone can try other method. Whatever the force vector field is minus y plus I minus y plus I minus y plus 1. I'm sorry. Force vector field is minus y plus 1 I. Okay. Then is it path independent or not? Then let's calculate the curl and check if it is path independent or not. What is minus y plus 1 minus in bracket y plus 1 bracket close I? If that is the case, then along x-axis y is 0, then it is minus I. It is like this. It is going like this. If I grow in y, then it will be, the quantity will increase and it will be in y direction only. If I go along negative y, it will be I again, but the quantity will increase. So if I say y equal to minus 2, minus 2 plus 1 is minus 1, minus minus gone I. So along the negative y, force is along x-axis. Along positive y, Force is along like this. Can you see? And force is growing and it is in opposite to x-axis. If I come down, then force is also increasing, but in this direction. Will it produce a torque? Anyone would say it will produce a torque. If I have a line like this and one is pushing like this and one is pushing like this, it will produce a torque. Prove it. df2 by dx. There is no f2, so gone. df1 by dy. df1 by dy is minus 1. Means it will produce a torque. How much is the work done moving